In this tutorial, we will evaluate composite functions that are represented in table form and in graphical form. We'll start with the table. So we have a table of values where the top row is our input, x. Our first function is f of x, and our second function is g of x. And we're asked to evaluate f of g of 1. Another way of denoting this is f parenthesis g parenthesis 1. So in essence, we want to think of this as finding the value of the function f at an input value that's equivalent to g of 1. So we'll look at the table. At an input of 1, the value of g of 1 equals 0. So the expression I'm interested in can also be thought of as f of 0. So now we'll look at an input of 0 up on the table, and the equivalent value of the function at 0 is negative 1. So the answer to my problem, f of g of 1, is equal to negative 1. Now my next expression that I'm interested in is g of f of negative 1. So you see the first thing you want to evaluate is f of negative 1, which according to the table is equivalent to negative 3. So now I want to find g of negative 3. I can again look at my table. G of negative 3 equals 8. So g of f of negative 1 is equivalent to 8. Now here we have two graphs. There's the graph of the piecewise function f of x and the graph of the polynomial function g of x. And we're asked to find g of f of negative 1. We can also think of it using notation like this. So once again, we'll start with f of negative 1. Let's look at our x-axis. At negative 1, the value of the f function is 1. So we can find g of 1. We'll look at our x-axis at 1, and the value of the curve g is equal to 4. So my original problem, g of f of negative 1 is equal to 4. Now let's find f of g of 4. We can write it this way. We'll start with g of 4, looking at your x-axis at 4, finding the value of the g curve. So the value of the function g at x equals 4 is 2. So we want to find f of 2. Let's look at our x-axis at 2. The value of the function f is negative 2 at that point. So the original problem, f of g of 4, is equal to negative 2.